Let's say that you had a twin, and that twin decided to take a high-speed rocket trip across the galaxy. Your twin would come home to find that you and everyone else has aged drastically. Meanwhile, they've only aged a day. The twin paradox is the most common example of the phenomenon known as time dilation, perceiving time differently relative to someone else. This phenomenon can be seen in greater detail in the Doctor Who episode World Enough and Time, where the Doctor and his companion are stuck on two opposite ends of a spaceship. The problem is, one end is slowly being sucked into the gravity well of a black hole, while the other is reversing away from said black hole. This causes the Doctor's companion Bill to wait years on her end. Meanwhile, the Doctor only experiences mere minutes. How is this possible? Ladies and gentlemen, I present to you the daggone Doctor Who time dilation dilemma. Yep, that's what we're going with. To answer this question, we have to look to Einstein's theory of relativity. Without getting into too much long, complicated nerd stuff, we know through Einstein's theory that two things can affect the perception of time: acceleration and gravity. We all know that when you move faster, it takes less time to do something. And this is exactly what the Doctor is experiencing on his end. Because his end is flying away from a black hole, he is accelerating at incredible speeds. Similar to how the Earth hurtles through space at a whopping 30 kilometers per second, or 67,000 miles per hour. But because he is moving way faster than any of us, our typical Earth hour would be nanoseconds for him. But Rooster, I hear you say in this weird voice that I gave you, that doesn't explain how Bill experiences years on her level. And you would be right. On her level, Bill's velocity is not high enough to make a difference like the Doctor's. Instead, Bill is being acted upon by a different force: gravity. So, how does the same force that keeps us tethered to Earth affect time? Well, it's easier if I just show you. Essentially, what we have here is a homemade gravity well. This model is designed to be a depiction of how general relativity works. This sheet represents spacetime, a level plane in which the universe resides. Let's say this ball is Earth. Notice how when I place it in the center of the sheet, it creates a dip. The slope created when I place the ball in the center represents both the gravitational pull of the object as well as the change in spacetime. So, when I place this smaller ball on the side, notice how long it takes for the marble to reach the center. Now, let's take this larger object to represent a black hole. Because black holes are so massive, they have an incredible gravitational pull, and as a result, warp spacetime way more than a planet like Earth would. Notice how the marble moves to the center faster thanks to the gravitational pull. This is why gravity is calculated like acceleration, or as 9.8 meters per second squared on Earth. Therefore, the greater the gravitational pull, the faster you accelerate and the slower you perceive time. Whoa, okay, now hold on. The slower you perceive time. But you said that Bill was experiencing time faster than the Doctor. And I did, but I was also a little bit misleading. While the immense gravity of the black hole is acting on Bill, it's important to note that the spaceship is currently flying away from the black hole, or trying to at least. When Bill and the Doctor first arrive, the spaceship is pretty much stopped in one place. This means that Bill is not experiencing time as slowly as if she were closer to the black hole. This also means that the spaceship has to be moving at ludicrous speeds, which means that the Doctor is moving at ludicrous speeds, which leads to the Doctor's perception of time being much slower than Bill's. In conclusion, while time dilation seems like something only seen in science fiction, it's actually a real phenomenon that can be measured. And while you may never experience time dilation quite like the Doctor and his companion, or the twins from this intro or Matthew McConaughey from that really long movie. The point is, I'm bad at outros, and time is relative, so make the most of the time that you experience. Ladies and gentlemen, I have been your host, the Rooster, and as always, have fun, stay safe, and be cool. I'll see you next time. Hey everybody, thank you so much for watching this video. This video was inspired by the brilliant minds over at Film Theory and Because Science. So if you like this video, be sure to leave a like and subscribe and check out their channels. Until next time, have fun, stay safe, and be cool.